Hi everyone. Um, Welcome to the part 2 of my data cleaning challenge explanation. I had to cut it off yesterday because it was getting a little bit too long, and I'm trying to avoid it from reaching an hour because I feel like, personally, if a video is up to an hour, sometimes I get bored and, I just stop watching it. You understand? So when I noticed the the length of the video is getting up to an hour, I just had to cut it off and then start a new one today. But this new one won't take much. Like, it won't take longer. It won't be as long as the first one. That's what I'm trying to say. So without me wasting much of the time, let me just go. This is where I stopped yesterday. So I was telling you about this height colon. There's no uniformity in it. There are values written in centimeter, and there are also values written in foot and inches. 6 foot 4 inches. We can't, if we are trying to make an analysis on power using Power BI, or using any form of EDA approach to make an analysis, we can never get an accurate result. The result will be clustered. The result will be, it won't be straightforward. And as a data analyst, these are things we have to correct when cleaning a particular data frame. That frame has to be clean. There has to be uniformity in each column. It has to be in the right data type. There shouldn't be any form of null values, or if there are going to be null values, it has to be like for a very specific reason. Duplicates should be, those are the things a data analyst look out for. So now, seeing this particular kind of colon in our data frame is a no-no. We can't have values written in foot and inches and some written in centimeter talking about the same thing. So what I have to do now is to define a function to make everything uniform. And the uniformity I'm picking now is to turn everything to centimeter instead of inches, foot, and centimeter. So to do that, I have to define a function. I like defining it. I like defining a function because is very easy to execute, and it works perfectly. I can also use a lambda. There's also a function called lambda. I can also use the lambda function and apply it, but then that lambda, I don't know. I just prefer defining anyway. There's something I noticed in Python data cleaning, and it's not just data cleaning. Like the Python language itself, like you can have up to 10 different approach to get one particular result. There's no uniform way of saying you want to get. It's just like saying we can add different number to get 10, which is true. You can add 5 plus 5. You can add 5 plus 5 to get 10. You can add 6 plus 4 to get 10. You can add 9 plus 1 to get 10. You can add 10 plus 0 to get 10. That's just the way it is in Python as well. You can have different approach to get a particular result. So to get the particular result I want of uniformity, I just chose the approach of defining a function and then applying that defined function. So I defined a function called convert height, and then I gave it a conditional statement here. The if statement is a conditional statement: if, else, elif, so I use that in the definition of the function. So if x minus 1 equals this, what this particular if statement, this first one, what is talking about is if x minus 1, this if x minus 1 is just if x minus 1 is the index. There's something they call indexing. The index of this x, because this is an x, this is an x in the colon, this is an x in the colon, everything here is an x. So the index of this colon is written as 0 from the left to the right is 0 1 2 3 4, 0 1 2 3 4, 0 1 2 3 4, 0 1. You get the logic. So those are the index of this x in the colon. So but then if you want to start from the right instead of the left, it's written as -1 -2 -3 -4 -5 instead of -0, because we can't say -0. -0 is nothing. So -1 -2, but starting from the left is 0 1 2 3 4. So now I use this indexing rule. If x -1, that means if the last, you know what I said about -1. So I said if the last word, or if the last string in x is equals to this particular sign here, which is the inches. Yeah. If we have it in x, if the last line contains these inches, definitely I'm talking about these ones, not the ones with centimeter, but these ones with inches in them. If x contains inches, then x, we have to replace the slash button with nothing. What that talks about basically is we have to replace this slash here, this backslash. We have to get it off and get it off this colon, and then to talk about the inches, that's int x2 colon, this 2 colon. What this talk is also in an indexing form, you know, all this 2 colon this bracket 2x brackets 2 colon. What this is talking about is also the indexing. So what this is talking about is, if aside the 0 1 2 0 1 2, okay, what this is talking about is, aside the first 2 colon, we have to multiply. What this is talking about is, aside the first 2 colon, multiply the last one by 2.54. You understand? So what this is going to do is, aside this 6 and single quotes sign here, the last one, which is talking about the inches, you multiply it by 2.54, and then we do the same for the foots. The foot is the first index here, which is 0. So you multiply 0 by 30.48, and then you return the addition of the multiplication of the inch and the foot. You return the addition and round it up. You understand? That's what this definition is talking about, because I'm trying to change this inches and foot to centimeters. So this is the code to turn it to centimeter. And then elif is talking about else if the last string in x is equals to m. Definitely the ones with centimeter, this is the ones I'm talking about, the ones with centimeter, because it's the ones with centimeter that have m in them. So elif the last string in x is equals to m, you return the int of x whole minus the last 2. You understand? You return whole except the last 2. This particular stuff is called index. It's an index. The index of the string. The index of the string in x. That's what this. I'm talking like I'm explaining this like I'm trying to teach. I'm explaining this like I'm trying to teach someone instead of just explaining it. So let me just explain it like I'm explaining it. Okay. So basically, I'm defining a a I'm defining a statement here to change the foot and inches to centimeter. So after defining the statement, all I did was to apply the defined statement. This is the defined statement here. So all I did was to apply this defined statement into the column, into the ith column. So after applying it and it worked, I'll now take this applied colon into the colon itself, to make it. I can also do in place equals true, but then I just felt, okay, let me just use this because there's no definite way to do. We can do a lot of things we can achieve a result in multiple ways with using Python. So I just had to use this. So then if we check the unique, unlike checking the unique, when we check the unique at first, we saw that is 170 centimeter, this centimeter, that centimeter, this inches, this foot. It's not a structured way. But now what we have is a single form of approach, just definite. And now instead of having the centimeter in them, we can just have the centimeter in the colon. So what I had to do was just to change the colon name to centimeter. So I did the same thing. For the weight colon, but the weight colon is more straightforward because there are just two values there. I can either change the value to kilogram or lbs. So I just thought, okay, let me change it to kilo. Since the most used conversion is the kilogram, let me just change everything to kilogram. So that's what I did. I defined a statement. I defined a function of weight kg in kg. So if lbs, just like the conditional way I told you at first, if there is lbs in this colon, the interpretation of this stuff is, if there is lbs in this colon, replace that lbs with nothing, and then float the particular value in that colon, and then multiply the float by this particular 0.45 blah blah blah. Because if you want to change that, if you want to convert from lbs to centimeter, you have to multiply the value by 0.45359237. So that's just what I did here. I had to float it after removing this lbs. I had to float it, so it's going to be. I can also do an int because I can multiply an int by a float, but I cannot multiply a string by a float or a string by an int. You understand? So I just chose float because this is also a float. So I just had to do floats. I just had to multiply a float with a float. So x equals float x times this, and then the result x is going to be, after getting the multiplication, is going to be a float. But talking about the centimeter, we don't want to talk about the centimeter in a float. We want to talk about it in a whole number, and to talk about it in a whole number, we have to change it from being a float to an integer. So that's just what I did there. I made x an integer and then returned x. Else I returned whole, except all these are already in kilograms already. So else, this is what this is doing now, is to give out all the first 0 1 0 1 0 1 0 1. It's going to bring the 0 1 except the last two, which is -1 -2. So except this last two, return the remaining value. That's what this is talking about. So after defining this statement, I applied it to the weight and then converted it to the weight column itself and renamed it to have the kilogram in it, because we can't have the kilogram in the value itself. So I put the kilogram in the colon. So now if you check the head, you find the kilogram in the weight. Let's check the weight and height colon. Mm, width and height, width and height, width and height, width and height. Aha. So this is it here now. You can see it, width and height. You can see it now. Now it has a structured record. So change the joint to this time. Yeah, let's check the joint. You can see the joint. You can see the way it's written. June 1, 2004. June. Yeah. We can actually leave it like this, but then I don't think we can. If we leave it like this, I guess the joint statement. I guess the joint colon is an object data type. Let's check it over here. Let's check it over here. Joint. Joined. I don't know. Let's have to increase the. I'm not seeing it clearly. Joint. Yeah, this is it over here. Yeah, I said it. It's an object. It's not supposed to be an object since it contains date. So we can either change it to a date data type or change it to a date time data type. So what I did was to change it to a date time data type. So this is it. So to do that, df.joint, which is the colon, is going to be equals to, I can do df dot joint too, but I just chose to do df in brackets. You know, it's just a choice for me. Pandas dot, this is the code, pandas dot to date time. You know, if I want to change, I can also do as type. I can also use an as type code, but then pandas already have its way already of changing a colon to a date time. So I just have to do pd dot to date time, and then imputed the colon I want it to change it to. I imputed the colon I want to change to date time. So now this is the value of it. It's now written like this. This is now the value of the joint. So if we check joint now, where is it? See now, see the way joint is written. Very structured way. Very clean and structured way. That's good. That's good. So now the next thing to work on is the release clause, the wage, and the value colon to suit their respective positions. So first I'm starting with the release clause. The release, these are currencies, they are written in currencies. There are some that are written in like, just if you check the uniques, you can see that 138.4 million euros. Look at the way it's written. Doesn't make sense. It's not structured. We can't get a, if we are trying to work on this particular colon using a visualization tool, we cannot get the accuracy. Okay, let's say we want to talk about the sum of the release clause. How can we get the sum of the release clause with this particular value? We can't. We can never get an accuracy in the value of the results from the sum. So what we have to do is to change it to its actual numeric form, and then get rid of the euro sign. Perhaps you can put that at the colon as well. So what we have to do is to change this, remove this currency, and then get the actual value of this 138.4 million euros. So to do that again, we have to use our favorite function, the definition of a function. I define the release clause, and then if m in x, there are two, there are two, there are some that are written in k, which signify thousands, and there are some that are written in m, which signifies millions. So what I did was, if there is m in x, which signifies the millions, we have to remove the m first and change it with nothing, and then float that particular x and multiply it by 1 million before rounding it up. You understand? After doing that, then we round the result up, and then we do the same for k. If there is k in x, remove the k and then float k and multiply multiply the value by 1000 and return the round value. So after defining this statement, I just imputed it into the release clause and applied it. No, I applied it first before imputing it into the release clause. So now if we check the uniques, these are the values. Instead of 138.4 million, we are having 138.4 million written in its actual form. 1, 2, 3, 1, 2, 3, 138.4 million. So the release clause is fixed. We do the same for the okay. After that, I now renamed the colon to have the euro sign in it. You can see it over here. So the euro sign is there. So if we check the end now for the release clause, look at the way the release clause. Now we can have the, if we want to make an analysis and get the sum of the release clause, we can get the actual value of the sum of the release clause instead of having 138k. You know, that doesn't make sense. These are the things that the data analysts have to look out for, you know, to get accurate data. So we do the same thing for the wage. You define the statement for the wage and then apply it and, you know, impute it into the wage column, just like it over here. If there is k in x, most of the values, if we check here the wage, of course no player can receive a wage of millions, so definitely everything has to be in k. So if there is k in x, we have to replace the k with nothing and then get the, aside from the first one, get the, aside from the first one, get the remaining value and then multiply it by 1000 and then return x, else return x except the first one. That's what this code is, this definition is talking about. So after applying it, it worked. You can see it worked perfectly. So I renamed the colon to have the euro sign, and then I did the same thing for the value. Defined the statement, and then I, you know, applied it and then imputed it into the colon. And then here we have it. I renamed it just like that, and that's all. After doing the whole cleaning, this is the table now. You can see that everything is perfect. Let me run everything again. I want to run all these cells. Run all. Boom. There won't be any error. There will not be any error. Everything is run. So I'm thinking of, before saving it, maybe I should rename. I'm thinking of renaming this colon. What does the colon talk about basically? FIFA challenge. Colon description. The overall rating of the player. Okay, I can just change it from OVA to from having, because the reason why I'm thinking of changing it is because it has this sign in it, this down sign, and I don't like it. I want it to, you know, so I'm thinking of changing it. So now from this to overall, so let's see. Boom. So now if we check the head, oh, it didn't work. Column must be the same length key. Column must be the same length key. What does that mean? Hold on first. Let me see this. df dot rename columns equals from this to this. Of course it's correct now. Why is it not running it? Hey now, is it supposed to run it now? It worked. So I wonder why. It's probably because okay. So after renaming it, I have to just okay. Let's see this. Doesn't allow column to be created via new attribute name. Okay, that means you still have to use this. Because I'm trying to wonder why. It didn't work at first and then later worked. Hold on. Let's see this. So definitely you have to use this and this. I put this in a string. So why is it not working? Why is it not working? Column must be the same name. Or should we do it without this? Let's see, because that arrow is really making the work look somehow. Also, let me see. Let me run this again. So the overall is still there. The overall is still there. So I have to, Control C. So let's okay, we can just use in place. Let me see if I can just use in place. I can just simply use in place to see how it goes. Okay, so df does rename rename colons equals this overall. Control C. To be overall. Let's see that. Okay, it worked. And then we can simply just try in place. In place equals true. So let's have a double. I hope it works this time. Boom. Oh my, still didn't work. It still didn't work. I don't know why. So it it's still going to have to be this equation sign df dot overall control c v equals invalid, because this arrow of a thing is, and if I remove the arrow, it's gonna just see the fuck. Okay, control C. And that doesn't allow colon to be created. So what could be wrong? That arrow is really giving issues. The arrow is really giving issues. I don't know why. I don't know even why. No, sorry. I'm supposed to remove this. Why is it not working? Like, colon must be same length as key. Of course, we renamed it. Or should I put the in place here? Because I'm trying to. Did it work? Let's see. I don't know if it worked though. I doubt if it worked. Let's see. Here dots head. Woo! It worked. Wow. That's so funny. Cause oh my. That's funny because that's just the solution. I'm supposed to put the code into this. I was just wondering, like, this code is correct, so why is it not working? Though it's changing it, but then it's not like changing it totally. It's just like changing it for display. But when I'm trying to like impute it into the colon itself, I guess it's because of this arrow. This arrow is causing the issue. This arrow caused the issue basically. This arrow. Had it been is just words, I'll be able to use that. You know, I'll be able to use the way I was doing it. But then I don't know why this. I guess, but I'm glad it worked. I'm glad it worked. So now we get the point of. That's just the way it is. You know, all these codes I wrote from the beginning to the end, like all these codes. It actually took me 3 days to get it right. I won't lie. It actually took me 3 days. It's not something. I'm not saying I'm a pro on Python. That wherever I have all the codes written in my head and whatever, you know, that's not the way it works. But what matters is I know what I want. I know what I want and I get what I want. You understand? So that's just what matters. So you know, I had to rack my head. It's not as if I just took the data set and I start writing the code like, okay, I know what code will work for what, you know. So but then I don't have to get it right, just like what the situation faced now with the changing of colon name, you know. I had same issues while writing my while writing my functions. Sometimes, you know, the functions won't work. I have to look at the code again, like, why is this function not working? But this is correct. Why is it not working? and like scrutinize and check and then I get the answer. So that's just the way it is. That's why we say data analysts have to spend more time cleaning their data. Now, after achieving this clean data, because of course this data is now clean. Look at it. Look at the columns named. You know, everything perfect. The values in them perfect. No situation. No. Now I can actually load this new data frame into Power BI or Tableau and get accurate data analysis, accurate visualization. So that's the point basically. That's the point. So I guess I just have to stop the presentation now, and it's nice. Just watch out for my next video. I'm going to have a next video. So